Okay, today we're going to talk about the nature of matter. We're going to get some basic chemistry going here, which will help you for next year in chemistry. So, matter. Matter is defined, as anything that has mass and occupies space. So, last time I talked about living things. This doesn't matter if you're living or non-living. We're just talking about basic things that have mass. We know they exist in solid, liquid, and gas, and now even we know that they can exist in a thing called plasma. Okay, all matter, both living and non-living, is composed of 92 natural elements. It's called the periodical table, which I will show you a picture of in a second here. Now, interesting enough, 98% of your body mass is really made up of 6 elements. And even of those 6 elements, it's really 4 elements: carbon, hydrogen, nitrogen, and oxygen. Then you have phosphorus and sulfur. But really, we call this chinops. So again, chinops is good to write down: carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. And you'll become very familiar with just these 4 right here, because they pretty much comprise everything that's in your body. Okay, so interesting enough, if you look at the Earth's crust right here, what's made up of, and the human body, it's kind of similar. Even the non-living and living things are made up of mainly oxygen. Carbon is what our mass is made up of. If you take the oxygen in our body, most of that's attached to water. But it's interesting to see how similar we are in certain elements on our body. If you look down here, this picture here, these are all the different elements in the world, and compared to us and the Earth's crust. Interesting enough, very similar. Okay, so an atom. An atom is the basic unit of matter, just as cells are the basic unit of life. In an atom, we can break it up into 3 small things, which you guys should be familiar with, right? We have protons, which are positive, and neutrons, which have no charge. Both protons and neutrons pretty much weigh the same, about the same amount of mass. Electrons have a negative charge, and look at that way. They really don't weigh anything at all, but they kind of float around the nucleus of the atom. And I'm going to show you a picture here. So, if you look at this is the periodic table of elements. This shows you all of the elements in the human body. And again, let's see if you can remember what's the acronym that most of our body is made up of. See if you guys can remember that. It's chinops: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Chinops. And again, you're going to become very familiar with these things. And most of those are located over here. You have carbon, you have oxygen, hydrogen's over here, phosphorus and sulfur. So, we're going to talk about what this number up here means, the top number, and what that bottom number means, because those numbers are very important depending on how many protons and neutrons are in the cell. So here is your subatomic particle, an atom. Your atom is made up of a nucleus in the middle, which is made up of protons and neutrons, and then you have these tiny little things floating around this nucleus area called electrons. Electrons are negative. So again, protons positive, neutrons have no charge, and electrons are negative. Now, this one's kind of interesting. This atom is actually helium. Helium has 2 protons and 2 neutrons and 2 electrons. So, each box in the periodic table has this. It has the atomic number, the atomic mass, and then the chemical symbol. The atomic number right here, the atomic number is the number of protons inside of the atom. So let's see here. This is going to show us the number of protons. I think my font is a little bit too big here. This bottom number here is called the atomic mass, and that is going to be protons plus neutrons. So, if you do the math here, 12 minus 6 is 6. That means there are 6 neutrons. Now, the number of protons, the number of protons is always going to equal the number of electrons, which makes sense because these are positive and these are negative. You want those two to balance each other out so the atom is neutral. Now isotopes. Isotopes are atoms of the same element with a different number of neutrons. So if we take a look down here, if you look right here, this is carbon right here, carbon 12. But now there's a carbon 13 and there's a carbon 14. Well, remember I told you, subtract these two numbers, the atomic mass from the number. This will give you 6. 13 minus 6 will give you 7. And 14 minus 6 will give you 8. That means this one has 6 neutrons. This carbon has 7, and this one has 8. These are called isotopes. They have a different number of neutrons. And a lot of atoms have that. And sometimes if they have too many neutrons compared to protons, they become unstable and they give off energy, which we can use, as I hear it, look at this, you can use it to date things, as in date how old fossils are. You can use them as tracers to find cancer. Many things you can use them for, but a lot of them are radioactive. If you take a look at this, this is showing you, this is Bohr's models of atoms. This is something I might ask you to draw from time to time. So if you look at hydrogen, it's the simplest one. You have the nucleus right here, and then you have just one electron. That's it. And you notice 1 minus 1 is 0, so there's no neutrons in there. Now if you come over here to carbon, carbon is 12, 6. It means it has 6 protons, and then 12 minus 6, let me just get my thing here. So it has 6 protons, has 6 neutrons, because 12 minus 6 is 6. And then remember, the number of protons equals the number of electrons, so it has 6 electrons. So if we take a look at this, instead of drawing all these little tiny protons and neutrons in there, they just clumped it all together and called it the nucleus, right? Which is made up of the protons and neutrons. And the key thing I want you to look at now is the outside of these rings, called electron shells. This is where the electrons, those little negative fields, are floating around the nucleus. And this one's on the outside. And notice this one has 3 rings. We won't deal with anything that has 4 or 5. We'll deal with mainly the first two rings, or shells they call them. The first shell right here, as you can see, can only hold 2. Can only hold 2 electrons. The next shell can hold 8 electrons. And then the third shell can hold up to 18, but really we're just going to deal with 8 on the third shell. Okay, and let me show you what I'm talking about here over here. So I'm going to show you an atom, oxygen. Oxygen is 8O16. Okay, let's see if you guys can remember this. That means it has, that top number is the atomic number, which gives you the number of protons. This number down here in the bottom is the atomic mass, which gives you the number of protons plus neutrons. And this is protons, which also equals the number of electrons. If oxygen has 8 protons and 8 electrons, let's draw it right here. So here we're going to do our here. We're going to have our nucleus right here, which consists of, right here, this number, right? 8 protons and 8 neutrons. We're just going to draw a big ball. And now we're going to do the electrons. Okay, here's our first electron shell. And then here's, we need another one. 2 of them. All right, let's delete something here. Let's delete this because let me start over again here. So I'm going to draw oxygen here. I'm going to do the middle here. So we have right here the nucleus. Remember, it has 8 electrons. That's going to be very important to know. The first ring is going to hold 2 electrons. Right? So then here's 1 electron, and here's another electron. That's 2. It's happy. The next shell, or ring right here, can hold 8. Remember, the first level can hold 2. The second level can hold 8. So 2, I need 6 more. So I have 3, 4, 5, 6, 7, 8. 8 total electrons. But if you notice, I have 2 in the first shell and 6 on the outer shell. That means on this outer shell, I need 2 more. It can hold 2 more. Now, most atoms like to be full. They like their outer shells to be complete. On oxygen, it needs 2 more electrons. So our next section we're going to talk about is how they get bonded together. Now I'm going to try that. I'm going to do this one more time for you guys. I'm going to do a different one now. I'm going to show you carbon. Carbon is 6. Let me write this out. Carbon is 6C12. So I'm going to draw my nucleus here, which has 6 protons, 6 neutrons. My first shell is going to have 2 electrons. There's 1. There's 2. Remember, I have 6 electrons because there are 6 protons. So I need 4 more. So I need another shell. So I'm going to do 1 right here. 2, 3, 4. 4 plus 2 is 6. And now if you look at the shell, remember the shell can hold 8. If I have 4 electrons here, carbon really wants to have 4 other electrons to be happy. And we're going to show you what happens is that means atoms are going to bond with other atoms, which we call chemical bonding. And that way they can share electrons with each other and both people can be happy. And that's when we get compounds. So, like I said, when you get atoms that bond together, you get a compound. Okay? And the reason why they're bonding together is because their electron shells that we talked about, those shells, they're not complete. They don't have 2 or they don't have 8, right? So if they don't have that 2-8 number, they're going to want to bond with other molecules. And usually you write them out like this. Right here, here's CO2, which we're familiar with. That means you have a carbon atom bonded with 2 oxygen atoms. Hydrogen here, you have 2 hydrogen bonded with 1 oxygen. So this is just showing you these atoms that bond together only because their electrons shells are not complete. The only atoms that don't bond together are gases. That's why they're gas. They're just floating around, right? So helium has 2, and that means it fills its first shell and it's happy. So again, looking at this, this is 6 carbons, 12 hydrogen, and 6 oxygen. All right, so here's our first bonding, right? So we have 2 bonds we're going to talk about today. This is very important. The first one is called ionic bonding. All right, in an ionic bond, this is when those electrons are transferred from one atom to another. Okay, I'm going to show you a pretty simple example of that. Okay, sodium has only 1 electron in its outermost shell. 1. That means it's going to have 7 others bonded with it. Most likely not. Most likely it's going to get rid of that 1. Chlorine has 7 in its outer shell, and so it only needs 1. So when chlorine and sodium get together, chlorine will steal 1. 1 electrons will transfer over, and making it complete with 8. And then sodium loses that 1, and they're both happy. Let me show you what that looks like. If you look right here, here's sodium. It has 3 shells. And the third shell, which needs a lot more than 1 to be happy, it gets rid of it. So when it gets rid of that electron, chlorine picks it up. If you look at chlorine, it has 1, 2, 3, 4, 5, 6, 7. It needs 1 more to be happy. It's going to take that to make it 8. Now remember, electrons are negative. So if that's the case here, chlorine got an extra negative electron, making this a more negative than positive. Now because sodium here lost a negative electron, it becomes positive. Well, as you know, opposites attract. Positive and a negative will come together, forming an ionic bond. So that's what an ionic bond is. When you have a positive and negative charged atom coming together. Now this is, by the way, this is a weak bond. It's not very strong. And when you put sodium and chlorine together, guess what you get? You get table salt. Table salt is sodium and chlorine together. That's what an ionic bond is. Now, the other type of bond are called covalent bonds. Now, covalent bonds, right here, result when two atoms share electrons. So this is not when somebody takes one away or you give up one. So there's no positive and negative. They share electrons. And sometimes you can have a single covalent bond. Sometimes you can have a double covalent bond when they're sharing two electrons. So if you look right here, this is carbon. If you remember, carbon on its outer shell had 1, 2, 3, 4. It needs 4 more. So it can bond with 4 hydrogen, which also need 1. And then now in here, they are forming a bond right there. That's a covalent bond, covalent bond, covalent bond, covalent bond. Now the oxygen we breathe, if you look over here, the oxygen we breathe is a double covalent bond. Right here, look at this. These ones right here, this area right here, they are sharing each molecule is sharing 2 electrons with the other. And if you remember oxygen had 6. 1, 2, 3, 4, 5, 6. It needed 2 more. So both of them needed to share 2 electrons. And this is a very strong bond. You're not going to be able to break an O2. And this is the O2 you breathe. So that's a covalent bond. Okay. So this is just the structural formula. Sometimes we will write it out. Instead of drawing these crazy figurines, which take for a long time, we just go like that. So if I were to draw CO2, for instance, so let's just go right here. You have CO2. You have a carbon here, and you have 2 lines like that, like that. Because remember, oxygen needs two electrons, so that each line represents a bond. So if you look right here, this carbon has 1 line. That means it's sharing 1 electron with each of them. Oxygen is sharing 2 right there. And that's today's lesson. I know it's a long lesson, and we'll review it when we get back to class.